Hi. So today we are going to discuss about instruction tuning. So this paper introduces this concept and is titled as fine-tuned language models are zero-shot learners. So here what they are doing is they take a pre-trained model and instruction tune it on a certain number of datasets and then inference on another set of datasets. So what they fine tune on is the datasets where they introduce some instructions. For example, so they already have a pre-trained model here, and then they fine tune it so on suppose two datasets, common sense reasoning and translation. So for common sense reasoning, they will have some instructions which is not there originally in the dataset. So introduce some instructions and some input and output. Similarly, here also they have instruction, input and output. Similarly, they will have some more datasets. And here, the inference is on a completely different dataset. Here also they will have some instruction, given some input, what is the output. And what they found was, so they named this model, which is fine-tuned on instruction, which is instruction tuned, as FLAN, which stands for Fine-Tuned Language Net. It's a 137 billion parameter pre-trained language model, which is again instruction tuned on 60 NLP datasets. So what they found was that it performs better. So FLAN with zero shot performs better than GPT-3 zero shot as well as few shot. So this is the definition for instruction tuning. So fine-tuning the model on a mixture of more than 60 NLP datasets expressed via natural language instructions. We refer to this resulting model FLAN for fine-tuned language net. So this is the gist of the different methods they are comparing against FLAN. So pre-trained fine-tuned BERT and T5. So here they have a pre-trained model and then they specifically fine-tune on a task and infer it on the same task. For GPT-3, there is no fine-tuning and it is directly improved via few. So they just use few-shot prompting to infer task. For instruction tuning, there is a pre-trained model and then there is a bunch of the task which have the instruction and it is inferred on the task. So the difference between these two is there is only one task it is fine-tuned on and inferred on one. Here it is a bunch of datasets plus the instruction templates. So that's the difference here. So let's talk about the different datasets and then the model which is used as a pre-trained language model and then the result. So for the datasets, they have 62 text datasets divided into 12 clusters. So the one which have this red tick, those are the clusters which are used for evaluation and the rest of them for fine-tuning. And for each dataset, they have 10 unique templates. So what it means is you pick any dataset, they will have 10 variations of instructions and 10 variations of the different instructions. And for each, and also 10, along with these 10 templates, they also have 3 templates where they turn the task around. I mean, for example, if you have a sentiment classification, we include templates asking to generate a movie review. So it's like turning around the requirement of the task. So in totally for each dataset, you will have 13 templates. So we already talked about the evaluation split. For the model, they use a decoder-only transformer language model, which 137 parameters. And this model is pre-trained on a collection of web documents, dialog data, Wikipedia, and tokenized to using BP tokens. And they refer this as a pre-trained base language model. And for instruction tuning, you can go through what exactly they do for instruction tuning, but the idea behind it has already been explained. For each training example, they limit the number of training examples per dataset to 30K. And they follow the examples proportional mixing scheme from refill. So let's talk about the results. So the first result is that the model FLAN works very, like it performs very good on natural language inference, reading comprehension, closed book, and translation. No, not this. Like they perform better on few of the datasets. Like natural language inference, they have better performance. So here, if you see the results, the supervised model, it was explained here. It's like BERT or T5. So we have the pre-trained model, fine tune it on suppose NL, A and LI, and then also inference it on the same dataset. So this one always has better performance than any of the results, but it is compared against the base language model with zero shot and then few shot, and then GPT-3 model with zero shot and then few shot, and then FLAN with zero shot with average template and best template. So average is the average of all the 10 or like 13 templates. And you can see like this triangle is with respect to few shot GPT-3, which is here. So they have very good performance as compared to these two models. And for how many tasks? Natural language inference, reading comprehension, translation. So the FLAN performs better in some of the data sets, but there is also a limitation for this model, is that once that when the downstream task is same as the original language modeling pre-training objective, instruction tuning does not help, which is interesting to look at. And there is some ablation study which was done. They studied like if suppose what happens if we slowly increase the number of clusters. So in the first one they have just summarization task, second they added translation, so they increase the clusters one by one and then they fine tune it, so it's like consistently increasing, so which implies that performance may improve with even more clusters added to instruction tuning. The third result is it's about a question like how much instruction tuning are affected by model scale. So these are the scales of the model, and what they found was as you increase the model parameters, the instruction tuning surpasses the untuned version, and these are for held out task, the unseen task. And for seen task, it's always better. But for unseen task, it hurts the performance for smaller models and it increases for bigger models, which is again interesting to see. And the probable reason why it hurts the performance is because all of the model capacity is used to learn the mixture of instruction tuning rather than the task itself. The fourth result is about if we increase, so till now we were all talking about FLAN, zero shot, when it was fine-tuned with instruction and one example. Now if we increase the number of example it is fine-tuned, so for example for every sample it is trained on, it will have one instruction and label, then instruction, label, and instruction and label. So there are multiple examples in one sample. And they capped it to 16. And what they found that the few shot FLAN has a better performance than zero shot FLAN. So if you see here, like for almost, even for this, there is a slight improvement, but there is still some improvement. So it's an interesting paper, and for more details, you can have a look at it. So that's all for today. Thank you.